Imagine a place where the laws of physics, as we know them, cease to exist, or gravity, so powerful that it warps the very fabric of space and time, bending light into impossible curves and trapping everything that dares to come too close. This isn't the plot of a sci-fi movie, it's the reality of a black hole, one of the most extreme and enigmatic phenomena in the universe. And if that's not mind-bending enough, consider the possibility that these cosmic monsters might be connected to something even stranger. Wormholes, hypothetical tunnels that could bridge distant parts of the cosmos or even different universes entirely. But how much of this is grounded in real science, and how much is just theoretical speculation? Let's unravel the mysteries of black holes and wormholes, separating fact from fiction. Black holes begin their existence in the fiery death throes of massive stars. When a star many times larger than our Sun exhausts its nuclear fuel, the outward pressure that once balanced its immense gravity vanishes. The star collapses under its own weight, exploding in a supernova so powerful it can outshine entire galaxies for a brief moment. What remains is an unfathomably dense core, a singularity where matter is crushed into an infinitely small point. Surrounding this singularity is the event horizon, the black hole's point of no return. Once anything, be it gas, planets, or even light, crosses this boundary, it can never escape. The gravitational pull is simply too strong. But the strangeness doesn't stop there. Near a black hole, time itself behaves in ways that defy common sense. Due to the extreme warping of spacetime predicted by Einstein's theory of general relativity, time slows down dramatically the closer you get to the event horizon. If you could somehow hover just outside it, ignoring the fact that you'd be torn apart by tidal forces, an outside observer would see you moving in slow motion, almost as if you were frozen in time. Meanwhile, the black hole's gravity would stretch you into a long, thin strand in a gruesome process scientists call spaghettification. Needless to say, this is not a journey any human or any known object could survive. Despite their terrifying nature, black holes are not just cosmic destroyers. They play a crucial role in shaping the universe. Supermassive black holes, millions or even billions of times heavier than our Sun, lurk at the centers of most galaxies, including our own Milky Way. These colossal entities influence the motion of stars and gas around them, helping to structure the galaxies they inhabit. Some even blast out enormous jets of energy, shaping the cosmos on a grand scale. Now, let's turn to wormholes, the hypothetical shortcuts through spacetime that have fueled countless science fiction stories. The idea is simple yet staggering. If space can be bent, perhaps it can be folded, creating a tunnel that connects to distant points in an instant. Think of it like a cosmic subway system, where instead of traveling the long way across the universe, you could step through a portal and emerge light years away in the blink of an eye. The concept isn't just fantasy. Einstein's equations actually permit the existence of wormholes, known technically as Einstein-Rosen bridges. But just because the math allows for them doesn't mean they exist. There are enormous obstacles to wormholes being real, let alone usable. First, they would require a form of matter with negative energy, something that, as far as we know, doesn't exist in nature. This exotic matter would be needed to prop open the wormhole's throat, preventing it from collapsing the moment it forms. Second, even if wormholes could exist, they would likely be incredibly unstable. The slightest disturbance, a single particle of regular matter entering the tunnel, could cause it to snapshot or explode. Then there's the question of where wormholes might lead. Some theories suggest they could connect different points in our own universe, making interstellar travel possible. Others propose that they might bridge entirely separate universes, opening doors to realities with different physical laws. There's even the eerie possibility that some black holes could secretly be wormholes in disguise, though falling into one would still be a one-way trip with no guarantee of survival. So, could humanity ever harness wormholes for space travel? At our current level of understanding, the answer is almost certainly no. The energy required to create and stabilize a wormhole would dwarf anything we're capable of producing, and the risks would be unimaginable. Even if we somehow found a naturally occurring wormhole, attempting to pass through it could be suicidal. The forces inside might be lethal, or the exit could dump travelers into a hostile region of space, or worse, a different time entirely. Yet, the allure of wormholes persists. They represent one of the few theoretical ways that faster-than-light travel might be possible without outright breaking the laws of physics. Some scientists speculate that advanced civilizations, if they exist, might have discovered ways to manipulate wormholes turning them into cosmic highways. Others suggest that microscopic wormholes, by constantly flicker in and out of existence at the quantum level, far too small and fleeting for us to detect. Black holes and wormholes challenge our understanding of reality. They force us to confront the limits of our knowledge and imagine possibilities beyond our current grasp. While black holes are undeniably real, confirmed by observations and even photographed in 2019, wormholes remain in the realm of theory. But that's the beauty of science. Today's wild speculation could be tomorrow's breakthrough. Every discovery about black holes brings us closer to understanding the deepest mysteries of the universe. And who knows, perhaps one day, we'll find that wormholes are real after all. Until then, the cosmos keeps its secrets all hidden. The universe is vast, strange, and full of wonders we've only begun to explore. Black holes and wormholes remind us that reality is far more bizarre than fiction, and the greatest adventures in science are still ahead of us.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.